All right, so let's look at question 3. 2-methyl-butene and pentane are structural isomers with molecular formula C5H12. And the first question says to define structural isomerism. So essentially, structural isomerism or structural isomers So structural isomerism occurs when compounds have the same molecular formula but different structural formula. Then they say draw the fully displayed structure of 2-methyl-butene. So butane, we know that the longest carbon chain will have 4 atoms, 4 carbon atoms. So that's 1, 2, 3, 4. Then the branch will be a methyl group, which is a CH3 group. And this branch will be on carbon number 2. Carbon number 1, 2. CH3. And of course, we can put in our other H's, other hydrogens. All right. So the next question says draw and name one other structural isomer of C4H12. So another structural isomer is actually 2,2-dimethyl propane. So we're rearranging how we form isomers. You can form it by doing another branch group here. So as you can see, this is 2-methyl-butene. We have one branch group on carbon number 2. We can have 2 branch groups on carbon number 2, right? If you do this, some persons might do this, put a branch group here and a branch group there, instead of putting it on the same. The thing about this, and I'll show you, the longest chain would be 4, and the branch group would be on carbon number 2, which is what we just did. So the longest chain will be butene. The branch group will be on carbon number 2, which is a methyl group. So it'll still be 2-methyl-butene, right? So you have to be careful when you're drawing your isomers. And also, if you check out our Instagram page, we have tips on a video with tips on how to draw isomers. So let's put in our hydrogens. So put in our hydrogens and let's name it our longest chain. Our longest chain has 3 carbons, so that's propane. And carbon number 2, we have 2 branch groups here. And carbon number 2, we have 2 branch groups. Both of them are methyl. How do we name this? It becomes 2, 2, because you have 2 branch groups on carbon number 2, hyphen, separating your words from your numbers with hyphen. You separate numbers from numbers with a comma. Dimethyl, di because it's 2-methyl group. So dimethyl propane. Propane being the longest carbon, straight carbon chain. And that's your isomer. B says ethanol can undergo various reactions. Depending on the reagents and the conditions of the reaction, products with different functional groups can be formed. What is the functional group of ethanol? Well, that's your hydroxyl group. Table 2 summarizes the conditions and products of two reactions of ethanol. Complete Table 2 by inserting the reaction, conditions, and drawing the fully displayed structure of the products which will be formed. Take note that the type of product to be formed is given in the table. So Table 2 summarizes the conditions and products of two reactions of ethanol. Complete Table 2 by inserting the reaction conditions and drawing the fully displayed structure of the products which will be formed. Take note that the type of product to be formed is given in the table, right? So this is between ethanol, and we're going from ethanol to alkene. Of course, this alkene will be ethene, right? So what are the conditions? So I'm going from alcohol to alkene, in this case ethanol to alkene, ethanol to ethene. So the reaction, this is a dehydration reaction. When you go from alcohol to alkene, this is a dehydration reaction. Dehydration, and the conditions are reacted with sulfuric acid at high temperature, so about 170 degrees Celsius, and you get your alkene. So the reagent, we're reacting with CH3COOH, this is ethanoic acid, so carboxylic acid. So alcohols and carboxylic acid gives us an ester, and of course, just concentrated. We use concentrated sulfuric acid again and heat, and we form our ester. And of course, we need to draw a fully displayed structure. We know that this is ethene, right? Alkenes have a double bond. And let me get some space here. Show you how I form the ester. So first, we're reacting the alcohol with a carboxylic acid, right? So our carboxylic acid, which is ethanoic acid, plus our alcohol, let's draw that out. Functional group there. Right? And of course, it's a condensation reaction, so you lose water. Right? So H2O. It's reversible. So you form your ester. This is your acid portion of your ester. This is your alcoholic portion, alcohol portion. That's your ester. So it's CH3. Here, C double bond O, double bond O. The next portion will be the alcohol portion. O, C, CH2, CH2, right? And this is a functional group of our ester. And that's how you form your ester. And this, the name of this ester is ethyl ethanoate. Of course, you draw that in your space right there.